Hey everyone, it's Mr. Aarons. We're doing 5-9 powers of products and quotients today. This is the last section of chapter 5, and then we'll be getting into some studying and some test taking. All right. So today we're going to be working on multiplying powers. There's some special rules that we have for this, but before we do that, I want to show you why this works. So the first thing that we have is we have 4 times 2 to the third power. And I rewrote this as 4 times 2 times 4 times 2 times 4 times 2. 3 times, because we know it was 4 times 2 to the third power. That means times by itself 3 times. After we do that, we can do something different. We can use the commutative property. We used this a while back. This told us that we could rearrange problems as long as they were all multiplication. So here's what we're going to do. We're going to rearrange this, and I'm going to write this as 4 times 4 times 4 times 2 times 2 times 2. So I rearranged it using that commutative property. Got all my 4's together, got all my 2's together. I'm then going to use my associative property, something else we talked about. That has to do with our parentheses here. So I'm thinking I want to put these in parentheses as 4 times 4 times 4 times 2 times 2 times 2. Finally, I'm going to rewrite that as 4 times itself 3 times, which is going to be 4 to the third power, times 2 times itself 3 times to the third power. We could solve that from there. I'm not super worried about that quite yet. But what I want you to notice is how this turned into this. All we really did is we took this 3 and we kind of distributed it to the back side of everything inside there. All of the factors inside these parentheses we gave to the third power. That's kind of a cool little idea that we're going to be working on today. What I want you to do right now is make sure that you get this in your notes. This is super important. This is our rule for raising a product to a power. So right here we have an example of 5 times 3 to the fourth power. And just like I did up here, without all those long steps, the rule is that we can do this automatically, distribute that right back there and right there to make this 5 to the fourth power times 5 to the third, or 5 to the fourth power times 3 to the fourth power. So I took this fourth power, distributed it to everything inside. Here's what this would look like if we did it with variables. So we put that m to each thing, and we have a times m times b times m. And I just put this in here because we still can't forget to simplify when we're doing things like this. This would not be our final form. We would still have to simplify from there. But a little bit easier for you. So let's practice that a couple times here. I'm looking at number 1. I'm going to take this 4 and I'm going to pop it to each thing here. So I'm going to pop it on here and I'm going to pop it on here and make this 2 to the fourth times p to the fourth. That simple, that easy. All we have to do after that is to simplify that as 2 times 2 times 2 times 2. 2, that's going to be 4, it's going to be 8, be 16, and I'm going to get 16 p to the fourth would be my final answer right there. This is going to be the same thing as writing 2p times 2p times 2p times 2p, except for it makes it pretty easy for me to simplify there. I don't even have to worry about combining those p's because I already did it for myself. So yeah, quick, easy way, just pop that onto the back of each. Let's try it one more time with 2. This one looks a little funky, but really all we have on the inside here is we have a 2 times 3. If I just go like that, and then we have outside parentheses, we're going to pop that 3 onto each and make this 2 to the third times 3 to the third. From there we can simplify. I know that 2 to the third is 8. 3 to the third is going to be 3 times 3 is 9 times 3 is going to be 27. And 8 times 27. Second time, I'm going to pop that in my calculator. Times 27. And we're going to get 216 for that. So again, all we're really doing here is we are taking this number and popping it onto the back of each. Sometimes it gets a little trickier. Here is another rule I want you to make sure you get down. We have our powers to powers rule. What's going to happen here is we have added powers before. You've seen things like, for example, right here, if I had 3 to the fourth times 3 to the sixth, we knew that we were allowed to add those up and make that 3 to the 10th. We practiced that a while back. Just like if we had division and we had 3 to the sixth over 3 to the fourth, we knew we could subtract those and make that 3 to the second. But what if we have something like this, where we have 2/3 to the second power? Well, let me show you something. So I have 2/3 to the second power. What I'm going to change that into is 2/3 times itself twice. 2/3 times 2/3. From there, this is a problem that we know how to do. All we have to do is add those two up and get to 6. But what we're allowed to do instead is take this 3 and multiply it by that 2. This isn't going to make a whole lot of sense with this small problem, but you'll see examples where this will make more sense. So we're going to do 3 times 2, and that's the powers to power rule. If we have a parenthesis dividing these two things up, you can really just multiply them together to get 6. We get the same answer here. Right here, I wrote it out as 2 to the third twice, added those together. But what we can do is we can just do 2, 3 times 2. So this right here is going to be your formula for that. A to the nth power to the n power really just means a to the m times nth power. So take a look at this one right here. I want you to follow along and hopefully be able to solve this one with me. I'm going to write this out as using this same logic as x to the 4 times the third. And from there, I'll get x to the 12th. I can just multiply those together. It's that simple. It's that quick. It's a little cheat code right there. Otherwise, if I were to write this out normally, it would be like this. X to the 4th 3 times. And then we would add those up from there. And we could get x to the 12th. And you'll notice we'll get the same answer there. This just makes it a lot easier for us to do. That's that powers to power rule. And I'll show you why that is helpful right here. Sometimes you will have things that look like this. So here's what's going to happen. We're going to pop this 5. We have x times y to the second power to the 5th power. We're going to pop this 5 onto the back of both of these. This is going to become x to the 5th times y to the 2nd times the 5th power. Take a close look at that. Absorb that for a second. We took this 5 and we popped it onto the back of each. Every factor inside there we popped it onto the back of. And this one already had one. It was y to the 2nd. So we popped this back on and made it y to the 2nd times the 5th. And then finally we could simplify that to y to the 5th, or x to the 5th, y to the 10th. And again, if we wrote that out, we would get the same idea. We would have x to the y squared times 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 x to the y squared. And again, that could become x times y squared. This is going to take a bit here. And like that. And we don't want to do all this writing. Why would I want to do all this? Because then I have to divide it up again and put all my x's by each other. It's a whole deal. See how long this is taking me? I don't want to have to do all this. Oh, and then there I finally realized I have 5 x's, x to the 5th, and I have y to the 2nd 5 times, but I can add those all up, make y to the 10th. But why spend all of that time doing that when I can just take this and pop it onto the back of each and get the same answer right here? So that's what I want you to practice doing. Look at number 2 here. We're going to pop this onto the back of each. It's going to become 5 to the 2nd power times x to the 3rd times 2nd power. And simplify that. This is going to be 25 x to the 6th. 3 times 2 is 6. Don't spend all that time splitting those up. Make it easy on yourself. All right, now we're looking at our negative signs. When we are working with negative signs, it is important that we look at the location. The location matters. Look at the difference between these two problems. We have one where the negative is on the inside, one where is it on the outside. Watch how these are going to be different. Using my PEMDA rules, I do parentheses first, and then exponents. These are my parentheses right here. My parentheses don't include my subtraction sign there, my minus sign. So what's going to happen here is we're going to start PEMDAs and then to our exponents. We're going to pop this onto the back of each. Negative 5 to the 2nd power times x to the 2nd power. Negative 5 times negative 5 is a positive 25 x to the 2nd power. There's our final answer there. Versus on this one, if we follow our PEMDA rules, We're going to do our parentheses first, and then our exponents, pop those on, and we'll get 5 to the second power times x to the second power. And we still have this negative sitting on the outside here. On this side, it was already included. It was on the inside, so we got to do make that negative times negative. Right here, watch what's going to happen. This is going to become 25x to the second power, and that negative is still sitting on the outside. So our final answer will become negative 25x to the second power. So that location matters. It's the difference between a negative and a positive. Let's look at one more example of this. So I'm going to take this 4 and I'm going to pop it onto the back of each. It's going to become negative 2 to the fourth power times y to the fourth power. This is going to be negative 2 times negative 2 times negative 2 times negative 2. That makes a positive 4 times another negative 2 is going to make a negative 8 times another negative 2 is going to make a positive once again, and we're going to get to a positive 16. So here we are. We are at 16y to the fourth. Check it out on this side. We're going to pop these onto the back first. We'll get 2 to the fourth times y to the fourth. 2 to the fourth we know is 16y to the fourth, but we still have this negative sitting on the outside. So the answer to this one is going to be negative 16y to the fourth. It's the difference between a positive and a negative. Location matters. That location of the negative side matters. Take that into consideration. All right, moving on to our quotients. I know this is a little longer one, but bear with me here. Our quotients pretty much work the exact same way. If we have a fraction like this, and we have a power on the outside, all you're going to do is you're going to distribute that to each thing. You're just going to pop it right in there. Look at how this turns out. 2 to the third power. 2 thirds to the third power, is the same as 2 thirds times 2 thirds times 2 thirds, which really, 2 times 2 times 2, we know how to multiply those fractions, is going to be 2 to the third power. 3 times 3 times 3 is going to be 3 to the third power. Take a look at this. A to the m over b. A over b to the nth power equals a to the m over b to the m. We're just taking this 3 and we're just popping it onto the back of both. This works as long as m is positive. You won't see anything where m is negative here for a while, so don't worry about that too much. So watch what's going to happen here on number 1. We're going to take this 4, pop it onto the back side of each. It's going to become negative 2 to the fourth over 3 to the fourth. All we have to do here is simplify. Top's going to be negative 2 to the fourth power, which I already solved up here. Is going to become a positive 16 with all of those negatives canceled out. And on bottom, we're going to have 3 times 3, which is 9, times 3 is 27, times 3 is 81. And we got to 16 over 81, and I believe that is going to be our final form. I'm going to punch in here for sake of time. Yep, and that would be your final form. So notice all we did there, just like for the multiplications, just pop it onto the back of each. I'm going to skip 2 for now, come back to that. I'm going to look at 3. Take this to the second power, pop it onto the back of each. We're going to get 3 to the second power on top, b to the second power on bottom, following this rule right here. And I'm going to simplify this. It's going to be 9 on top over b squared. Done deal. Last one, don't let it fool you here. We're taking this 3. We got a little bit of combination of everything that we've been working on. We're putting it all together here. 3, we're going to pop it to everything on top, not just once, all the factors, and once on bottom. So it's going to become 2 to the third. X, 2 times 3, all over 3 to the third. I popped that 3 onto everything, all of the factors there. Don't let it fool you. On top, 2 to the third power, that's going to be the same as 8 times x to the second times third is going to become x to the sixth, all over 3 to the third, which is going to be a 27. And we finalize with 8x to the sixth over 27. Pop that 3 onto each part of that. Don't let it fool you. Take your time with these. The biggest thing is just looking at them and making sure you're following all those steps right. If you need to go back and pause to get any of these in your notes, I'd recommend that. Otherwise, we're sitting at that 15-minute mark, so I'll send you on your way. Good luck.